Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are from group 6 of TSF1. We want to present about the chapter 3 geometry and trigonometry about polar coordinates. Before we start our presentation, let me introduce our team first. Alright, first, Muhammad Syukur Bin Ilias. Can we have your face right here? Alright, this is Syukur, and then the second one is Daniel bin Edi Tan, is me. And third one, Muhammad Nasyran bin Muhammad Rizal. Fourth one, Aiman Bin Abdullah.
Hello. Hello.
Let me. The fifth one is Muhammad Naqib bin Mohd Ruslan, and the sixth one is Faisal bin Zulkarnain. Alright, next, we want to proceed about the polar coordinates, about the introduction of polar coordinates. Let's invite our next presenter.
Okay, thank you, Daniel, for giving me this opportunity. Okay, introduction. Polar coordinates are coordinates in the form r theta, if you can see it, where r is the distance to the point from the origin, 0, 0. And the theta is the angle in radian between the positive x and the line formed by r. This all is shown in the diagram. In the diagram, we can see the r is like a radius to a circle, while the theta is this from the quadrant 1 to quadrant 2. Okay, let's move on. Okay. Cartesian coordinates can be also described in polar form as r theta. From trigonometry and Pythagoras theorem, we have the following relationship. But first, remember this sign is equal to opposite by divided by adjacent. Okay. What the hell? Sine is opposite divided by hypotenuse, and the cos that, and from that we can get that the x equal r cos theta formula, such as look at the picture above, picture below. You see this? How to find the x is r cos theta, because cos theta equals to x divided by r, same as well as the y. Okay, let's understand. So let's move to Daniel for example 1.
Saya tak boleh gerak. Wait. Why cannot? I'm sorry for the inconvenience caused. Wait, yeah. Alright, we proceed to the example. Alright, we have compiled the five example. Alright, the example 1 question. Convert -1 and more -1. This is coordinate into polar coordinates. Alright, first you need to remember what we call this, the equation r squared equal to x squared plus y squared, and the r is, we want to find r, we must move the square into the right side. That is square of x squared plus y squared, and we want to find theta. Theta is equal to tan -1 y over x. Alright, first, how to find the -1 into -1 into polar coordinates? First, we must find the r. But how? We use this, the second formula. Alright, r equal to square this x squared. We put -1 here, and y squared, we also put -1 here, and the answer is squared 2. Alright. Next, now let's get to the theta. Theta is, we use the formula of the third formula, tan -1. We put y and x in here, and we found the answer is pi/4. But remember, that is not the correct answer. However, this value of theta we found here is the first quadrant. And the point we have been given is the third quadrant. As not above, we can get the correct angle by adding theta pi onto this. Therefore, the actual angle is theta equal, we find is pi/4 plus pi. So the answer we got is 5 pi/4. So we substitute into polar coordinates, just what like Amir said before, this is polar coordinate, the point is square 2 comma 5 pi/4. So this is the polar coordinate. And now as well, that we could have used the first pi that we got by using the negative r. In this case, the point could also be written in the polar coordinate as negative square 2 comma pi/4. Alright, next we move to next presenter. That's Nasyran. Present the second example, please.
Wait for a moment. So we are going to proceed with the example number 2, which we want to convert -4 to pi/3 into Cartesian coordinate. So first and foremost, we must know the conversion formula, which is x equal to r cos theta and y equal to r sin theta. So we must determine the value of r, which is r equal to -4 and theta equal to 2 pi/3. After that, we just substitute the value into the formula, and we can get x equal to -4 cos 2 pi/3 and y equal to -4 sin 2 pi/3. So we settle the x equation first. So we apply the reference angle by finding the angle that is equivalent trigonometric values in the first quadrant. Hence, we make the expression negative because in the second quadrant, the sign of cosine is negative. So we can get the equation x equal to -4 in bracket negative cos pi/3. The exact value of cos pi/3 is 1/2. So we just replace it back in the equation, and we can get x equal to -4 multiplied by -1/2. We simplify it up, and we can get x equal to -2 multiplied by -1. So we can get x equal to, final answer for x is x equal to 2. Next, we proceed to the y equation, which is y equal to -4 sin 2 pi/3. By applying the reference angle, which we find that the angle that is equivalent to the trigonometric values in the first quadrant, we can get y equal to -4 sin pi/3. So the exact value of sin pi/3 is square root 3/2. Hence, we just replace it back in the question. In the y equation, we can get y equal to -4 square root 3/2. Next, we cancel the common factor of 2, which is we just factor out 2 out of -4. And next, we just cancel the common factor, which is 2 by 2. Cancel the 2 and 2. And then we rewrite the expression, which is we can get y equal to -2 square root 3. Hence, the Cartesian coordinates can be represented by the point which is 2 -2 square root 3. That's all. Thank you.
Alright, we're going to example 3. The question is about how to convert this function to polar coordinate. First of all, we begin with the conversion x equal to r cos theta and y equal to r sin theta. The example as below, you can see in the screen. First of all, the first step is just plugging those into our linear equation give. So the result it will be 2r cos theta minus 3r sin theta equal to 7, which means we just okay, whatever. To the next, now we solve for r to get r as a function of theta, and the result will be r2 cos theta minus 3 sin theta equal to 7. And that's our line in polar coordinate. So we just 2 cos theta minus 3 sin theta, we put it at the right side, and the last result will be 7 per 2 cos theta minus 3 sin theta. Notice that the equation for this line is more complicated in polar coordinates. Line are in the natural thing to plot in polar coordinates. So you can move to the next presenter, which is example 4. Thank you.
Okay, next we can see at the slide, which is example number 4. So the question is about convert the Cartesian coordinate to polar coordinate, which is 2 on the x-axis and -4 on y-axis. Okay, so we can see that first we must the most important thing, we must remember the formula, which is the radius equal the square root x and x square plus y square. So we just put into the formula and then we get the answer, which is 2 square root 5. Okay, and then it's exactly right. We the radius. So we can see at the graph, which is the coordinate at the fourth quadrant. As we can see, 2 on the x-axis and -4 on the y-axis. And then we cannot simply take the answer, which is 63.43 degrees, but we have to calculate it by minus the 360 degree minus with the 63.43 degrees, and we get the answer. Okay, next slide. Okay, so for the next example, which is example 5, the question is exactly the same like the example 4, which is we have to convert the Cartesian coordinate to polar coordinate, which is the Cartesian coordinate is -5 on the x-axis and 5 square root 3 on the y-axis. Okay, exactly like before, we can see that the formula is exactly from like the example 4. We just put it into the formula, square root x square plus y square. And we get the answer is 10. And then we see at the graph. We can see at the graph, which is the coordinate is on the at the second quadrant, which is -5 and 5 square root 3. And then we just simply sketch the graph, but we cannot take the degrees that we get, which is 120 degree. Before we get 120, we have to minus 180 with 60 degree that we get. So we get 120 for the answer. And then we can change convert the degree into the pi with the formula that has been given, which is the degrees times with pi over 180, and then we get the answer. Okay, we move to the next slide, which is application.
So we reach at application. So there are two applications that we found about geometric coordinate. Firstly, about spherical coordinate. So about spherical coordinates mean that it has one example of it, which is hydrogen. By using hydrogen atom, we know that hydrogen atom is in sphere shape, and so by using the pusat of hydrogen atom, we can make a Cartesian and calculate every point of hydrogen atom coordinate. Okay, secondly, about orbital movement. So about orbital movement ni, firstly we need to know about orbit. What is orbit? Orbit is gravitationally curved trajectory of an object. Look at the picture, the black picture, which is the image supposedly to be moving around the red dot. So as an example of this is our planet moving using orbit, around the trajectory of orbit around the sun. But what is the relative with chemistry? So the relative is let's look at picture 2, which is there is orbit in electron movement. So by using geometric coordinate, we can calculate the exact position of electron. So that's all from application. So that's all for us. Thank you.